watching that thing. So there we go. All right, today's lecture is on crap. Yeah, it's on crap. I want this to go away. All right, never mind. I give it. I probably didn't. All right, who cares? It's up there. Molarity. Now, will somebody take their key terms out and tell me what molarity is?
Let's see. Handy dandy notes.
Handy dandy notes. Read it to me. This is today's lecture. What is molarity? The number of moles of solute. Keep going. In what? In 1 liter of solution. Now, okay, abbreviation for solution is SOLN. All right, so now, guys, just for review, what is the most important concept in all of chemistry? No, it's not the atom, but good. What is it? The mole. Now, when I say molarity, do you hear the word mole? So what happens is this is only for solutions. Now remember, keep in mind that solutions are composed of 2 things. There's a solute. So yesterday's lab, the solute was KCl, that was the powder, and the solvent was the distilled water. And so solutions are composed of a solute and a solvent. And on some level, you need to understand that if you had a gallon of water and you dissolved 1 teaspoon of salt in it, it would be less concentrated if you dissolved the whole pound of salt. You get that solutions can have different concentrations, and this is how we quantify it. And when I say this, people kind of laugh at me, but I say it really fast. But molarity units are moles per liter, but I get going and I say mole per liter. And then my AP kids will sometimes say, what's a mole per liter? And I go, mole per liter. This is how we define molarity. And so this is review. Don't write this down. But you guys remember way back in the beginning of the course, we did the density triangle. Density equals mass over volume. And the reason why we do this, I told you, and I got to draw this because I'm recording it, but how it works is you put your hand over what you're solving for. So if you're solving for density, you cover up the density, and the formula tells you, the triangle tells you that you take mass and divide it by volume. But if you do the density triangle and you're solving for mass, then you cover up the mass, and mass is equal to density times volume because they're at the same height. Do you remember doing that? Now, we don't do that with molarity because that triangle, that pointy triangle, is not enough space. So when I do molarity, I do a molarity circle, and then put a circle and then put a big T in it because you go to tartan. And then molarity, like density was mass over volume, so you put mass on the top and volume. But here molarity is defined as moles per liter. And I do something weird. I put a V. And next to the V, I put a little L because that means the volume has to be in what? Liters. And so this is the molarity circle, but I'm also going to do this. This is a blast from your past. Underneath the molarity circle, in that top part, the biggest part, I put mass because, let's think back to yesterday's lab. You are never going to go over to a balance and measure out moles. You measure out mass, and then you use the periodic table to convert mass to moles. So this is going to be important when I get into how you solve molarity problems. But these 2 concepts, mole and mass, are very closely related by a concept called molar what? Mass. And where do you get, and I do M with feet sometimes, and for molar mass, because of Mr. T conquers over pervs, but molar mass is the concept in chemistry that relates moles and mass, and that comes off the periodic table. Okay, now, honestly, I haven't had a kid all day. If I go slow enough, everyone gets this. All right, here's the steps you do. 1, God, I've already been lecturing for 4 minutes and 43 seconds. 1, the first thing you do on a molarity problem is make sure the volume is in liters. It's the very first thing you do, because what is molarity? Moles per liter. It's not moles per milliliter, it's moles per liter. Now, I'm going to switch colors. Here's what you got to remember from this fall. 1 milliliter is the same thing as a cubic centimeter, correct? Now, come on, I'm almost done with the class. Cubic centimeter, that means you have a cube. Think of like a die. That's 1 centimeter on an edge. A centimeter is exactly the width of my pinky, that tiny. A cube, that's 1 centimeter on an edge, is tiny. That's what a milliliter is. And what's a liter? Not a cubic centimeter, but a cubic what? Decimeter. And again, I keep telling you this, but a decimeter is the length of a standard deck of cards. So if you have a cube that's, you know, a deck of cards long, wide, and high, that holds a liter. Now, figure a 2-liter pop bottle. So it's like half of a 2-liter pop bottle. And this is the most important one. Seriously, this is the most important one. There is 1,000 milliliters in a liter, just like a millennium is 1,000 years. And I don't even care if you don't use the factor label method. Here's why this is really important. I don't even care. You're at the point where you've got to be able to do this in your head. All chemistry is calibrated in milliliters. Would you guys agree? Graduated cylinders, burettes. You haven't used burettes yet. All my stuff is calibrated in milliliters, but molarity is moles per liter. So a lot of the times in chemistry, most of the time, I will give you the volume in milliliters. Like I'll say 500 milliliters. Well, you know that there is 1,000 milliliters in a liter. And we do that so much that just know this. If you're in milliliters and you want to convert to liters, all you're going to do is slide the decimal point 3 places backwards. And why do I say backwards? Because it's the opposite direction that you read, correct? Isn't that what dividing by 1,000 does? Chemistry, all chemistry glassware is calibrated in milliliters, but it has to be in liters. If you don't want to show the work, just slide it 3 places. You'll see that in my lecture. Okay, so step 1, the very first thing you have to do is you have to convert milliliters to liters, or you have to look at the volume. Step 2, this is crazy, and this won't make sense till I do my 3 examples. Step 2 is do what the molarity circle tells you. Okay, and I'm going to go over that over and over and over, and I don't know how I'm going to do this with taping this, but the beauty is second hour and third hour, I could like do half of the problem on the smartboard and half of the problem on the blackboard, but I can't do that. I'll come back when I do my examples and tell you what that means. It's just like the density. It's just like the density triangle. If you're solving for density, cover up density, and the triangle tells you to put mass on the top and volume on the bottom. That's what I mean by that. And then finally, use molar mass when necessary. Use molar mass when necessary. And it's almost always necessary. The only time it's not necessary is if they give you moles. And the factor label method. Now, this usually goes pretty well. All right, so I'm going to say this. In my 3 examples, I'm going to say this over and over and over again. What do you do first? Make sure the volume is in liters. What do you do second? What the circle tells you. What do you do third? You calculate molar mass and then use the factor label method to get the units to come out right. You guys okay? Okay, I heard a no. Now I got to flip over here and get my PowerPoint up. Which is not that big a deal. All right, now I'll go F5, and I got to go to slide 21. No, that is not what I wanted. Did I stop recording? Good, I did not. All right, I want to go to slide 21. All right. Whoops-a-daisy. Hold on. I don't want this here. Let me escape. One would think I would have checked this out. Well, let's pretend I didn't do this. Right. I do not. No, I don't want to get rid of all of it. I just want to get. All right, some interesting things are going to happen when I work this problem, and I'm going to have to work it a little different. This, you go. Probably should just close this and undo it. I could have probably just erased this up there, huh? All right. I tell you, not so good at technology. Okay, we are going to go to slide 21. All right, here we go. Now, I got to try to get this all wedged on here for the kids that are gone. Okay, now, guys, when you're doing a molarity problem, the very first thing I want you to do is I want you to look at the problem and find the volume. Is this the volume? Is this the volume? Step one, make sure the volume is in liters. Is it in liters? Check. Step two, do what the circle tells you. This is what this means. Draw a circle. What goes in the circle? A T, because you go to tartan. And molarity is moles per liter, but I put V sub L. And then mole is related to mass. And this is what I mean when I say do what the circle tells you. Now read the problem. Calculate the molarity. What are we solving for? Molarity. So if you're solving for molarity, you put your hand on top of the molarity, cover it up, and the circle tells you that in order to get molarity, in the problem, they have to give you moles or mass. And they have to give you one of them, because you can only have one unknown, and the unknown is molarity. They have to give you mass or moles, and it goes upstairs. And then they have to give you the volume, and then where does the volume go? Do you get what I mean by do what the circle tells you? It tells you that if you're solving for molarity, the circle tells you that moles or mass goes upstairs, and in the denominator, you're going to put in the volume in liters. I'm going to switch colors. Here's the mass, 200 grams. Here's the volume in liters, 1.5. And we're not done yet, because let's common sense this. What are molarity units? This is important. What's the definition of moles per liter? What are we in? Grams per liter. Grams per liter is not moles per liter. What relates grams and moles? Something you get off the periodic table called molar mass. Now, there's a couple things, and I'm going to have to get iron sheets for you, but okay, right here. On your iron sheet, magnesium is +2. Why is it +2? Because it's in column 2. Chlorine is -1. The formula for magnesium chloride is MgCl2. Is this a blast from your past? Now, I am going to get out my periodic table, and magnesium is 24.30, and chlorine is 35.45, but I have 2 of them. And so then when I add these together, I get 10 carry the 1, 12 carry the 1, 15 carry the 1, 95.02 grams per mole. Now, how many times in this course have we calculated molar mass? A whole bunch, correct? I would say probably approaching 300, if not more. All right, now here's the deal. Step 3 is calculate molar mass if necessary. This is when it will be necessary. If I give you mass, you're going to have to calculate molar mass. If I give you moles, you won't have to calculate molar mass. Why? Because what's the most important concept in all of chemistry? Moles. You're already in moles. You don't have to do anything. Now we're almost done. Once you calculate molar mass, this is from the first couple weeks of the course. If grams is on the top, where does the 95.20 grams have to go? On the bottom. So 95.20 grams goes down, 1 mole goes up. Keep in mind this 1 is implied. I like to put it in, but we say grams per mole. We don't say grams per 1 mole. So when you're doing, now watch, grams cancels with grams, This has 4 sig figs. This has 3 sig figs, and this has 4 sig figs. How many sig figs do we get? 3. And so when I type in, I'm going to 200 on my calculator times, and we don't have to do the 1, so we're not going to do the 1, so I'm going to erase that. Divided by parenthesis 1.5 times 95.2. If you do that on your calculator, you will get 1.40. Somebody who's, this is the 3rd time I've done this today, so I haven't done this. Now, what's the unit up, the only unit upstairs that I haven't crossed off? Moles. And what's the only unit downstairs that I have? Liters. And mole per liter is what molarity is. So this is my first of 3 examples that actually are going to go pretty quick. So what do you do first? Molarity is moles per liter. The first thing you do is make sure the volume's in liters. The second thing you do is read the problem, figure out what you're looking for, cover that up with your hand, and it will tell you if you multiply the other 2 numbers or divide them. And then the third part is calculate molar mass. All right, next problem. I love how this one is way down here. All right, calculate the molarity of a solution that contains 10 grams of sodium hydroxide dissolved in, okay, first of all, I probably should change this. Why would somebody write 500 like that instead of a normal person? Yeah, they wanted it to have 3 sig figs, because if you write 500 and don't have the dot on the, it only has 1. All right, so here's what you do first. I'm going to do it up here. First time you have a molarity problem, you look for the volume and you say to yourself, is that in liters? And the answer is no, because what is a cubic centimeter? The same thing as. What is a cubic centimeter? A milliliter. A cubic centimeter is a milliliter. Remember, little tiny cube, the width of my pinky, it's tiny. Okay, so right now we know that the volume is 500 milliliters, and to get from milliliters to liters, you slide the decimal point 3 places, because that's the same thing as dividing by 1,000. Step 1, is this exactly half of a liter? So 1 liter is 1,000 milliliters, so 500 milliliters is half a liter. Does that make sense? All right, step 2, do what the circle tells you. Now let me draw the circle up here. Here's a circle, here's T for tartan. It tells me moles or mass, because moles and mass are related. Molarity is moles per liter, but moles are related to mass by a concept called molar mass. Now again, calculate the molarity. We are looking for the molarity, and so the circle tells us to cover up the molarity with our hand. And in the problem, they're either going to give you moles or mass, and that goes upstairs, and then they're going to give you volume, and that goes downstairs after you've converted it to liters. So, is this the mass? So we have 10 grams of NaOH, that goes upstairs, and 0.500 liters goes downstairs. And here's how come. I know I'm not done. If I stop the problem right now, I would be in grams per liter, and I'm trying to get to what? Moles per liter. Now, this time, the stuff is sodium hydroxide. This is lye. And so on your ion sheet, sodium is 22.99, and oxygen is 16. And hydrogen is 1.008, and when I add those together, I get 39.998, okay, being obnoxious. But when you add, you count decimal points. This has 2, this has 3, this has 2, this has 2, this has 3. How many decimal points do you get? 2. And so the molar mass of sodium hydroxide is 40. This comes up a ton in AP chemistry because they don't get a calculator, and 40 is a nice whole number. Okay, now, step 1 is make sure your volume is in liters. Step 2, do what the circle tells you. Step 3 is calculate the molar mass and use your factor label method. Grams is on the top, people, so where does the 40 grams have to go? Bottom, or it won't cancel. So 40 grams goes down, 1 mole goes up, grams cancels with grams. Now I'm in moles per liter. Is that what I'm trying to get to? This is actually off an old AP test. Let's do the bottom. On the bottom, what's half of 40? 20. What's 10 divided by 20? Half. This is exactly a half molar solution. So 0.5 moles per liter. And the last thing I forgot to tell you is sometimes instead of moles per liter, they will substitute the abbreviation, which is capital L. All right, do you see how easy this is? Now I'm just going to do the last problem in my PowerPoint is, holy mackerel, I got to erase it. The only thing different about this problem, people, is that you're going to cover up a different part of the circle. So it says, okay, so calculate the mass of solute necessary to prepare 750 cubic centimeters of a 0.2 molar calcium chloride. All right, find the volume first. This is a cubic centimeter. What is a cubic centimeter? The same thing as a milliliter, correct? Step one, you have 750 milliliters. What does the volume have to be in? Liters. Now, you're going to almost always do that because all chemistry glassware is calibrated in milliliters. It's not calibrated in deciliters or centiliters. It's milliliters. You're all converting milliliters to liters. It's the only thing I'll ever ask you to do. How do you convert milliliters to liters? You divide by 1,000 or you slide the decimal point 3 places backwards. And here's the first thing. Is this 3/4 of a liter? So 1 liter is 1,000 milliliters. 750 milliliters is 0.75 or 3/4 of a liter. All right, step one, make sure the volume is in liters. Step two, look at this. Calculate the mass. For the first time today, we are not looking for molarity. They gave us molarity. It's 0.2 molar. What are we looking for? Mass. So here is my molarity circle. Make a circle, put a T. Molarity is moles per liter, and mole is related to mass by molar mass. Okay, now, this time, put your hand on top of the mass, correct? Because it says calculate the mass. Calculate the mass. And the circle tells you that in the problem, in order to calculate mass, they have to give you the concentration and the volume. Did they give you both? And so you take the concentration, which is 0.200 moles per liter. Now notice, I did something kind of interesting here. You can't use the abbreviation. What does capital M mean? Moles per liter. All right, and we just in step one figured out the volume. It is 0.7500 liters. Something interesting happens. The liters cancel. If you don't like that there's nothing down here, I don't care, put a 1. Some units in chemistry, some units don't have units on the top and the bottom. All right, people, if I stopped right now, what would my unit be? Moles. I didn't ask for moles. What did I ask for? Mass. So what relates mass and moles is molar mass. So calcium is Ca+2. Chloride is Cl-1. I crisscross them. I get calcium chloride. Now, calcium is 40.08. Chlorine is 35.45. And how many times do you add that? Twice. And if you do that, trust me, you get 110.98 grams per mole. That comes off the periodic table. Let's say this is the 301st time we've calculated a molar mass. Now I get problems. I wrote that in the wrong spot, so I'm going to rewrite it down here, 110.98 grams per mole. It's hard for me to get organized. All right. Okay, now people, this is what my notes say. Make sure the volume is in liters. Do what the circle tells you, and what that means is with the numbers that were given to you in the problem. The circle will tell you if you divide them or you multiply them. Does that make sense? Now, guys, moles is on the top. Where does the 1 mole have to go? Bottom. So in this type, and this is what I mean by use the factor label method, 1 mole goes down to cancel, and the 110.98 grams goes up. Look at every unit's canceled except grams, and you're looking for mass. Is grams a mass unit? And so now when you pull out your periodic table, this has 3 sig, or you pull out your calculator, sorry. This has 3, this has 4, this has 5. How many sig figs do we get? 3. So I'm just going to do on my calculator 0.200 times 0.7500 times 110.98. My calculator says 16.647. All right, I'm being obnoxious here, but I'm getting 16.647 grams, but I only get 3 sig figs. So is the best answer in chemistry 16.6. Now, tomorrow we will start the post lab, and then Friday you will finish your lab and finish this molarity worksheet. Now, you guys are out of here in about 15 minutes. Yeah, some of you guys are pretty darn fast. All right, hang on. Let me turn this off. Hey.